Where are we going?
To the Kennedy spaceship area.
Okay. Oh, ready?
Yeah.
Okay, let's go.
Forward.
We almost 9 minutes to Kennedy Space Center. The head of the that's the head of the rocket.
Kennedy rockets.
Yeah, Kennedy rocket.
You can see it from 2.7 miles away.
Yes, 2.7 miles away. Yes. Oh, that's too big, really. That's good. Kennedy Space Center.
And the line's gonna be longer than the laser tag line. It's the Kennedy Space Center.
Turn left.
Yeah, we're gonna make it in 1 minute.
Oh, traffic. It's for parking.
No.
Okay, we are in the parking.
And then we just gotta find
We
the
are in the
spot.
parking to find a spot.
Are in the area of NASA. I forgot the space station called.
Kennedy
Kennedy.
Space Center.
So it's a big ornament.
Entrance, yes.
Yeah, and look at the T.
Oh, you're in? Can I show the map? Oh yeah. We are in a space. Kennedy Space Center. Oh yeah, this is very good. Let's go.
We have another one to go.
Uh-huh.
That's thrust.
Oh, this is trust. That's a North Korean astronaut. Let's go in. What is this, Ryan? Yeah, you did. That's good. Go, go, go.
बराबर बजाने go this left 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 right 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 left 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 up 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 left right left 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 right 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 right
What else?
up and stay short. Again.
You have a time.
Okay.
Fast, fast. Go down, go down, go down, fast.
Fine. Keep it.
No, I just ran out.
اون سبزه تموم میشه. اون سبزه.
سریع
برو.
بگردم.
Go, 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 go. Go, go, fast. نه. برو پایین، برو پایین.
Fine.
Yes.
Yeah, successful lunch. Go. Go next.
Good job. Next one.
Oh, it's a robot. Whatever that is. I don't know.
And what is that? Is it food? Cookies. Food, 2 days. Food. Breakfast, lunch, dinner. Oh, this one. Okay. And look at this. Water, yeah. Food, container. Little bit.
Are those drawings from their kids?
Yes. This is the guys.
3D printer.
Oh, it's for their kids.
Science glove box makes it possible to do investigations in space similar to those done in ground-based lab work. It provides a safe environment for research in liquids, flavors, and other less expensive and handled investigation to make possible surely. I think that's everything.
Now, this last experiment that we have here, this is how NASA powers rockets. And what I mean by that is chemical reactions. This Falcon 9 on top of us, it uses a mixture called RP1, basically kerosene and liquid oxygen, and that produces power for the rockets. But here we have, all reliable, baking soda on top, vinegar at the bottom. Right now, no reaction taking place. Are you guys ready for this? In T-minus 3, 2, 1, we have ignition sequence start. And now, what do you see?
The balloon's blowing.
See all those bubbles? That's what we've created, that's our product, and that's carbon dioxide. But you'll notice our reaction starting to get smaller, spending energy, but at the same time, our balloon's expanding, getting bigger. Every action has an equal and opposite reaction. That's Newton's third law of motion. So, just vinegar, so I actually could not tell you truthfully. But see, Newton's third law, once these rockets build their pressure, it all pushes down against the launch pad. That's the action force, and the reaction force, the thrust that carries our rockets up. But in our case, very simple at-home chemical reactions. You can always use Alka-Seltz and orange juice, pre-reacted as well. Just be warned, Coke and Mentos, those are 2 reactors. Pretty 2 reactors. But once again, our products, carbon dioxide, chemical reaction, you have 2 reactants, 2 ingredients, combine them, and you get something else. And it's going to keep on getting bigger until our fuel doesn't have energy, which is just about at the end. It's a little homemade punching bag, if you want to give it a whack. Or a squeeze, there you are. And like I said, you can also use Alka-Seltz and orange juice, put the gas inside. There are lots of different at-home reactions you use as well. Now, my friend, do you guys have any questions on what you saw here today, the at-home experiments? I'm back, my friend. Well, I got a question for you all. What was that? I'm sorry? It had in a reaction, sure would. Well, like gas is producing, sure would. That one happened very fast, though. That's quite the reaction. Now, my friends, before you do go, I have a question for you all. Do you know, what do you call money in space? What do you call space money? We have one here at the park. It's very popular. It'd be Starbucks. Little space joke for you all. You guys, thank you for coming. I hope you enjoyed. We also have
look at this, dragon. Dragon too.
Fly, dragon, fly.
Okay, the first satellite, I think is this one. 1960 is the first satellite. Is this?
Marine Air Force, you win the prize. Bye bye.
Okay, goes to, this is Pioneer 678.
For second place. Bye bye.
1965.
And
Okay,
for the
let's
third place medal is Marine Air 100. Bye bye.
go. Okay, what's next?
The next one is Viking.
Viking.
See you later. And the next one goes. It just goes. Bye bye. Let's see
Let's go.
what's the newest.
Okay, slowly. 1980s, and then 1990s. These 4. 90. Oh yeah, this is good.
That's a lot. That's a lot.
Oh, this is lots of 2010.
Wait.
2020. Where's the next one? 2020.
230.
Yeah, they have a decision to do this one. 2030. Now is on this. And this. And this. And 2030 is this.
This one, these 3 hasn't even came out yet.
Yeah.
We're on this one.
Mm-hmm.
No wait, we're on 2024. We're on this one.
Yes. And
Oh,
maybe
and this
next
one.
one is this one.
Oh, when this video comes out, it'll probably be 2025. So.
Yeah, that's good.
So the newest one is actually nicer.
This is a
Newest one that we have.
yeah.
Bye bye. 10, 9, 8, 7,
Are you ready?
And let's see.
Kinda. I don't. What if it's a roller coaster?
This roller coaster? I don't think so.
No, it's,
Have you been on this? Is it a roller?
No.
I told you, you are going, is the screen, it's the same as the space. That's what I'm telling you, it was a different one, it has a lot of moving. It's not. I remember exactly what was that.
See.
Yes.
On one of the most exciting adventures in the universe, a visit to another planet. On today's tour of Mars, you'll see the red planet's rugged beauty firsthand and encounter one of its early robotic explorers.
Ready for launch.
Thank you, pilot. LD, EOS is go.
Confirmed EOS. Your go.
Roller coaster.
3,
2, launch.
1.
The dusty red
you
planet
return
we
this
know
to the
today
Mars?
didn't always look this way. A couple billion years ago, Mars was mostly covered in water. The mystery of what happened to Mars water is a big part of what the researchers at the Mars Outpost are studying. If we can understand what caused Mars climate change, we might be able to better care for our own planet. That big gouge in the surface is a canyon called Valles Marineris. It's about 5 times as long and 4 times as deep as Earth's Grand Canyon. We're coming up on Olympus Mons, the largest volcano in the solar system. It stands 3 times higher than Mount Everest, and it's roughly the size of the state of Arizona. Martian Outpost, this is EOS. Contact EOS. Including minerals formed in ancient water and the chemicals necessary to support living microbes. Perseverance's mission was to seek signs of ancient life and collect rock and soil samples to be returned to Earth for study. It also arrived with the Ingenuity helicopter, the first test of powered flight on another planet. With each successful test and discovery, Perseverance and Ingenuity brought us closer to getting boots on Martian soil.
Commander, a dust storm appears to be forming over the crater.
Visibility's dropping. We're going to stay low to avoid any damage to our heat shields.
ببند شده در کن به تپه میزنه They're not feeling something
Martian dust storms pose a real problem for equipment like solar panels.
No, not me. This is the chair.
The demise of the
Movie.
Steadfast Opportunity rover back in 2018. But now it's time to make the journey back home. To a world still lush with water and life.
EOS, Mission Control. Welcome back. Your approach is free of arriving traffic. Clear for landing on LC-73.
EOS copy.
exploring remotely via rovers or in person at the Astros, the exploration of Mars is full of exciting possibilities.
Is it good, Captain?
Welcome back to Earth. Unfasten your seatbelts by pressing the button on your right. Ensure you collect all your personal items from the compartment behind you.
What happened to your eyes?
It's so
After coming out from the dark, so bright, yes?
Wait,
Can I see your face? That's good.
The bug food is there.
Yummy, yummy, yummy. Let's go. Where's mommy? Ryan, where are we going now?
we're going to the bus.
On the bus, and then go to visit the really Kennedy Space Center shuttle.
Their glow guiding our travel for centuries. The more we learn about our universe, the more questions we have.
I'm Emily Calandrelli, and today you'll be following me behind the gates on this exclusive bus tour of Kennedy Space Center. Our journey will take us past active facilities and end at the visitor complex's own Apollo Saturn V Center.
But before we begin this journey, just like every NASA mission, our #1 goal is to return home safely. So always stay seated while the bus is in motion. Please, no food or drinks on the bus with the exception of water. Please keep conversation to a minimum so others may hear and enjoy the tour. No photography is permitted at the security gates, but there will be plenty of photo opportunities during the tour.
This rocket that you'll see standing tall in front of KSC's badging station is the Mercury Redstone rocket. It represents NASA's earliest efforts to send humans into space. These Redstone rockets were formerly ballistic missiles provided to NASA by the U.S. Army. In October of 1958, NASA formally organized Project Mercury with a mission to investigate man's reaction to this new environment and safely recover the capsule and its pilot. Man rating for human spaceflight on what was previously a ballistic missile was no easy task. After several modifications and test flights, a Mercury capsule carrying Ham, a chimpanzee, was successfully launched and recovered on January 31st, 1961. Just months later, on May 5th, astronaut Alan Shepard launched on a Mercury Redstone rocket, becoming the first American in space.
Alright, right here on our right is the Mercury Redstone rocket. That little black capsule on top is just like the capsule Alan Shepard sat in during launch. And it looks like it's on a blue stand. Well, that blue stand is actually the launch pad.
Hi, I'm Janet Petro, and welcome to NASA's John F. Kennedy Space Center, where NASA astronauts have ventured forth on flights of exploration since the 1960s. And what an exciting time to visit our multi-user spaceport. Through our Commercial Crew program, we are sending astronauts to the International Space Station from American soil for the first time since the Space Shuttle program ended in 2011. We're continuing to launch new research experiments and supplies to the space station with our commercial resupply services and launching the most technologically advanced scientific instruments to date into space through our Launch Services program. This all culminates in our ultimate mission, the Artemis program, where NASA will return to the moon, this time with the first woman and first person of color, and continue on to Mars. In all our history, there's been one common theme woven throughout our DNA. It's our insatiable desire to explore beyond our home planet in our never-ending quest to expand our knowledge of the universe. As you venture behind the gates, you'll find a community of the most talented, dedicated, motivated workforce anywhere in the world who believe in the unlimited potential of space exploration. This is an active spaceport where new things are happening every day. You never know what you might see, so enjoy your tour.
You are now approaching the Vehicle Assembly Building, or as NASA calls it, the VAB. It is one of the largest buildings in the world by volume, and is the place where NASA completes the final assembly of its rockets before launch. The sheer scale of this building is hard to grasp, even when you're right next to it.
Do you ever feel really small when you think about space? What about when you're standing next to a skyscraper or a really big bridge? Well, I feel about as small as an ant right now. I'm standing inside the Vehicle Assembly Building trying to grasp how large it really is in here. It has 4 bays. Each bay has 2 large horizontal doors below it and 7 smaller vertically opening doors above it, tall enough to fit the world's largest rocket through. In fact, these are the largest doors in the world.
Construction of the VAB required 65,000 cubic yards of concrete, 45,000 steel beams, 1 million steel bolts, amounting to almost 100,000 tons of steel. Notice the flag painted on the outside of the VAB? It's the size of a 21-story building. The blue section alone is the size of an NBA basketball court. Each star is 6 feet across, and each red and white stripe is wide enough for this bus to drive down. And the entire VAB? It's so huge that the Roman Colosseum would fit on the roof with room to spare for a parking lot. By volume, the VAB can fit 3.5 Empire State. And it would take 250 billion ping pong balls to fill it. It was built in the 1960s for the Apollo program. Every Saturn V rocket that sent humans to the moon was assembled right here. Every space shuttle mission also assembled within these same walls. After the space shuttle program, a major renovation to the inside of this building began to accommodate NASA's next generation of rockets, the Space Launch System, or SLS. Lockheed Martin has developed a capsule called Orion that will sit atop the SLS rocket. This capsule is designed to facilitate human exploration of the moon and eventually Mars.
It's known for dreaming big, and big dreams require big equipment. I'm standing next to the Crawler Transporter, the largest self-powered land vehicle in the world. It was originally built in 1965 for the Apollo program and has since been updated to accommodate the space shuttle and now NASA's SLS rocket. Weighing in at 6 million pounds and capable of lifting and hauling 18 million pounds, the Crawler is an engineering marvel, even without a rocket sitting on top of it. This thing has 2,750 horsepower V16 diesel engines that can carry the Crawler up to a top speed of, wait for it, 1 mile per hour while carrying a rocket. Keep an eye out for the Crawler as we approach this area. And remember, we are visiting a working spaceport, so while the Crawler may not stay in one area for very long, it's bound to be out here somewhere. Now, let me introduce you to my friend, John Giles, the Crawler project manager.
I'm standing in front of Crawler Transporter number 2 at Kennedy Space Center. Crawler Transporter number 2 will be used for the SLS program to take the launch vehicle back and forth to the pad. We will begin by going underneath the mobile launcher. We'll pick it up, we'll take it over to the VAB. They'll then assemble the launch vehicle on top of the mobile launcher, and then we'll come back to the VAB. We'll slide underneath it again, we'll pick it up, we'll take it out to the pad, a trip of about 4.2 miles. It'll take us about 7 hours to get there. But during our trip to the launch pad, we'll roll over a specially prepared crawler weight that consists of anywhere from 8 to 12 inches of special rock. Below that is limestone that's about 4 feet thick and compressed to hold the weight of the crawler and the mobile launcher. And then below that is some hydraulically compacted sand that can support all the weight. And then once we're there, we'll drop it all off. And then a few days later, there'll be a launch. We'll come back, we'll pick the mobile launcher up, and we'll bring it back to the VAB to start the process all over again.
With 50 years and some 3,000 kilometers or 2,000 miles on the clock, NASA expects the crawlers to be in operation for at least another 3 decades. How cool is that? The latest refurbishment is complete. complete, and preparation is well underway for the first SLS mission. The crawler will be doing what it was originally designed to do once again, which is moving rockets.
So here we are at the vehicle assembly building. That American flag on the side that they talked about earlier in the video, that is the world's largest hand-painted American flag. Those two high bay doors, and there's two on the other side, they are 456 feet tall and take 45 minutes to open. 82 shuttle missions launched from 39A, so imagine the astronauts that walked across that arm. Then at the end, it looks like a white rocket. That's the emergency abort system for the Orion. It sits on top of the Orion, and if there's a problem during launch or shortly after, yank the Orion off the rocket, take it a mile away, and parachute to safety. These three buildings in front of us used to be their orbiter processing facility. When the shuttle used to land, they would tow the orbiter into there to get it ready for its next mission. Now Boeing is using all three of them. The building with the blue mural on the side, that is a mural of the Starliner in orbit. Inside there, they assemble all the Starliners. Okay, as soon as we clear these buildings, we're going to see the Corolla Transporter. It is Corolla Transporter 1 because Corolla Transporter 2 is in the vehicle assembly building getting ready for Artemis 2. But they look exactly the same. There was an alligator there before, but not there. Alright, as soon as we clear these little buildings, you'll see the Corolla Transporter. Right there in the corner, see the tracks? There are 8 set of tracks. Each track has 57 cleats. Each cleat weighs 1 million pounds. That is a mobile launch platform from the shuttle era. And what's under construction is the mobile launch tower for Artemis 3.
Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
When President John F. Kennedy made this speech in 1962, he set in motion an era of discovery that would change humankind forever. 7 years after he spoke these ambitious words, the world watched as Neil Armstrong and Buzz Aldrin became the first people to walk on the moon. The achievements of the men and women who worked on the space program in these early decades of NASA helped propel the technology we use every day. NASA and the thriving private space industry at Kennedy Space Center today are the living legacy of their story. As we arrive at the Apollo Saturn V Center to learn more about that historic era, get ready to step back into a time when NASA had everything to prove to a nation focused on one goal: to be the first country to land a person on the moon.
Alright, straight ahead in front of us, through the trees across the water, that is Launch Pad 39A. That is SpaceX's launch pad. NASA leased Launch Pad 39A Up a little further,
The other side.
Those
The
three
other
lightning
side. You
towers.
see that?
That is launch pad 39B.
The other side of the
That is where the crawler transporter brought Artemis 1, and that is where they launched their new Space Launch System rocket with the Orion capsule on top. Artemis 2 is scheduled for September 2025. April 2025, and next time astronauts will be on board. Right here is the Moon Tree Garden. You're welcome to go here anytime you like. But when you get off the bus, there'll be 2 silver doors that will open at the same time. Well, they're open right now. I don't know for how long. You'll all go in and you'll start the tour together. When you leave, you'll exit through the Right Stuff gift shop out to the bus loading area. Where there, they'll put you on any bus that is available.
And first steps on the moon.
वसत बेहतर है
Please move all the way to the front of the theater to make room for the guests behind you. Our presentation will begin shortly.
اینجا نه بیا اینجا Ryan.
NASA Kennedy Space Center.
Ryan.
To the Apollo Saturn V. Our presentation will begin in a few short moments. For the comfort, safety, and viewing pleasure of all of us.
When I was a kid, I used to dream about flying through space. Every week on TV, I'd watch my heroes as they jumped into their rocket ships and took to the stars. And I wanted to be like them. They had courage, imagination, and no problem ever stood in their way for long. You know, in the end, when we actually did send men into space, it turned out that those were exactly the qualities it took.
I'm John Hudson. This is Pad 39 of the Kennedy Space Center. I was a launch controller here when from this very spot, man took off to fly to the moon. It was a journey that began 12 years before that rocket ever left the ground. And it started on the other side of the world.
Back then, we were one of 2 superpowers that always seemed to be on the edge of a terrible war. In 1957, the Soviet Union launched the first ever man-made satellite into Earth orbit. They called it Sputnik, which means traveling companion. And in a world where peace hung in a delicate balance, it seemed to create a dangerous advantage. Every ham radio operator in America could hear it beeping. People were afraid. Were the Soviets looking down on us? Watching us? If they could make a satellite pass over our cities, could they do the same with a bomb? Our own space program kicked into high gear, and less than 2 months later, we were ready to launch our own satellite. It was being called the space race, and we were running a distant second. In 1961, we fell even further behind. Soviet cosmonaut Yuri Gagarin became the first man into space, circling the world in just 89 minutes. We had our own astronauts, and they were eager and ready to take the big ride. But our manned space program couldn't seem to get off the ground. We stuck with it, and on May 5th, 1961, things finally started going right. Astronaut Alan Shepard took his ship Freedom 7 6.5 miles into space. America had its first space hero. Just a few days later, our space program received a new challenge. But this one did not come from the Soviet Union. It came from our young president. In one inspiring moment, he changed the mission from one based in fear of the present to one of hope for the future.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
We hadn't been more than 16 minutes into space, and now we were going to the moon. We would have to design a rocket the size of a 36-story office building, put it together with the precision of a microscope, and accelerate it to the speed of a bullet. Then we would have to guide it to a moving target 250,000 miles away. Many people thought it was an impossible dream, but 400,000 of us set about making that dream a reality. It would be the longest, most hazardous voyage that any man had dared to attempt. But step by step, mission by mission, we orbited the Earth, perfecting the skills and technologies we would need on this incredible journey. Our astronauts practiced maneuvering, docking, and the 1,000 other tasks that would comprise the moon mission. We created new alloys, lighter and stronger than anything seen before. We designed communication systems that would be reliable over the vast distances. And behind it all, we tried to perfect the rocket that would be powerful enough to punch out of Earth orbit and take us to the moon. One day, however, the dream of flying to the moon almost slipped away. It was January 27th, 1967. Astronauts Virgil Gus Grissom, Edward White, and Roger Chaffee were on board Apollo 1 for a plugs-out test, a full-scale dress rehearsal for the actual launch. Suddenly it happened. There was a fire in the capsule. 3 men whose lives had been in our hands were lost.
Surely the opening vistas of space promise high costs and hardships, as well as high reward. But this country of the United States was not built by those who waited and rested and wished to look behind them.
After Apollo 1, some thought we'd failed and that the moon was out of our reach. But we owed it to those men to learn from their sacrifice and to carry on. We started taking the Apollo vehicle apart piece by piece. Was the design flawed? Had safety been compromised? Tough questions. And we spent 1.5 years redesigning the spacecraft so that no astronaut's life would ever be at risk because we overlooked something or because we could have done something better. A moon rocket is 91% high explosive, and it goes into the most unforgiving, hazardous environment there is. We could never make it risk-free, and the men who flew them knew that. We didn't send men into space again until Apollo 7 orbited the Earth testing some of the new designs. When everything worked perfectly, the decision was made. The next mission would travel to the moon. It was mankind's destiny to leave the shores of our planet behind and strike out across the vast ocean of space. In the great span of our history, now is the time that we could. Now is the time that we would. We stood on the eve of the longest, most dangerous journey that any man had ever undertaken. And it would be taken by Frank Borman, James Lovell, and William Anders, the crew of Apollo 8. Through those doors, you'll find the firing room, launch control, just as it was on December 21st, 1968.
Please gather all of your belongings, take small children by the hand, and proceed through the open doors to firing room number 1. All strollers, wheelchair guests,
برو بشین برو بشین برو ما این تیتر نیست
Go inside, go inside. Come in.
نباید بشینی؟
Why did you turn it off?
It's turning off. برو.
بیا راه بلند کجا آدم
Look at the camera. You see?
This is a shuttle center, Bobo.
کجا برم؟ بریم بالاتر؟
No, let's go.
This is the firing room, launch control for the Apollo missions. This is not a mock-up. These are the very consoles we sat at when men first took off to fly to the moon. The tragedy of Apollo 1 had put us a year and a half behind. We were making up for it in one big leap, and we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas 1968 when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testament. "36 stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the craft. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone who was on the pad agreed. It was as though the rocket was alive, breathing, straining at the leash. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the waiting spacecraft. The minimum safe distance from a Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the pre-flight checks, our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems, and to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
TPSS
minutes and counting. We've completed our communications checks with the Apollo 8 astronauts in the cabin, and the communications are go. During this period, and once we do get the firing command, the various tanks within the 3 stages of the Saturn V launch vehicle begin to pressurize. We had firing command. The firing command is in. We are now on the automatic sequence. T-minus 2 minutes, 20 seconds, and counting. Our status board indicates that all aspects are ready. Instrument unit is ready. Spacecraft ready. Final check of the emergency detection system. That ready light also on. First stage preparations are completed.
All systems are A-OK. We're on. Ready to go to crossfire. Stand by, Walter. Okay, you're on.
All systems go. 1 minute 45 seconds and counting. The first stage liquid oxygen tank has been pressurized, and the pressure is still building up. Coming up on 90 seconds, mark T-minus 90 seconds and counting. The Apollo 8 crew standing by, spacecraft commander Frank Borman, Jim Lovell, Bill Anders. We now report that the liquid hydrogen tank in the third stage is pressurized. 1 minute 15 seconds. All third stage propellants pressurized at this time as we come up on the 60-second mark on flight to the moon. T-minus 60 seconds and counting. The vehicle now is completely pressurized. We're coming up on a power transfer shortly. We have the power transfer. We're now on the flight batteries within the launch vehicle. Final reports coming from Frank Borman at this time. Final look at the switch list aboard the spacecraft. 20 seconds, all aspects. We are still go at this time. T-minus 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3.
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. But it was the hundreds of thousands of men and women who worked in that team, and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. Now, on the other side of those doors, you'll find an actual Saturn V moon rocket. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly one on a second flight to the moon called Apollo 13. But that's another story.
Let's go.
Weiter vor. So.
Oh, this is inside. This is exactly inside of that capsule that they're sitting. Here is this one, right? Let's go down. Yes.
Yeah, Mr. Manes. I'm saying, do you like to do this?
No, this is not the real one. This is
Is that the real one?
yes, that's the real one.
Those are two.
Sorry.
Those are two rocket ships.
Yes, that's a two rocket. This is not a two rocket ship, Ryan. This is a one. There's a one piece, first piece, and this is second piece, and there's a third piece. This is the first piece. Okay, there you go. The first piece is going. The first piece is this one.
This whole entire section.
Or yes, and the second, the separate, and this one is a separate engine. And then the last one. It goes.
This.
Yeah, it goes there. And this one is going. So this one is the last piece. Is there. And this is open too.
The last.
Go landing.
And then it's just this.
Let's go to landing and the moon in this way.
That's how it works?
Yes. Let's do this.
Nie, mam wygrawerowany tył księżyca niż Japonia.
Here, go, continue. Walking. That, you know, that's it. At the end is that piece. In this piece. What is that?
Man on moon. First man on moon.
Mm-hmm.
The United States.
Man on the moon. This is newspaper in that side. Did you see the Hero Wait.
Today, right now we saw on all the failed rockets and the rocket that made it to the moon.
Oh, this is the moon? Look at the tire, Ryan. This is a metal tire. This is not a tire.
That's a weird looking tire.
And look at the shoes.
I mean,
Yes. Look at the hat.
one this side, one this side. Go there, I stand here. I take a picture for you.
This one is good. This is the one.
A lunar sample. 7,035,000,035.
No, this is sample number.
7,035,440.20.
Apollo 17, December 7, 1972. They bring this one to the Earth.
This BASA sample estimates to be 3.7.
This one. Display keyboard.
Lunar sample. What's a bag?
Checklist. Lunar surface map.
Television camera.
Television camera, Apollo 11. Oh, look at this.
Lunar scoop and lunar sample smooth. Nuclear activity training.
Who's this guy?
These guys are the three people. I'm pretty sure they land on the moon.
Land on the moon?
Yeah, Michael Collins, Neil Armstrong, and Edwin Buzz Aldrin.
Okay.
So we just finished the place we were in, and now we're going back to the bus after my parents buy these photos.
Alright, y'all are gonna access your
So yeah, see you at the bus. This is the cool tree, Tom. This is Tom. So if you are like at this area where I am right now, this is what Tom looks like. Say hi, Tom. And then if you get chopped down, that would be the new Tom. But right now, this is Tom, the tree man. He's cool. And yeah, we're going to the bus right now. Hello. We are going to go to the space shuttle to Atlantis.
very big.
The starship follows us.
Booster into its pieces. Rockets, fuel tank. It's supposed to be reusable. How do we get all those parts home? What if we just throw the fuel tank away?
We're writing all new processes, procedures, manuals. We've never had to reuse a ship before.
We're also going to have to build some really big garages.
Sir, what if she lands somewhere other than Florida? How did you get back here? It's a glider.
Buy her a plane ticket home.
Ablative heat shields are heavy, and they burn up on re-entry. We need a more reusable solution. Silica foam tiles, thousands of them, fitted together in one lightweight, reusable heat shield.
That'll hold up with the engines? Tell me some good news with the tiles.
The heat shield bond keeps failing. The tiles keep falling off.
So another delay. How long? How long?
1.5 to 2 years.
Well, this is going to be fun to tell my boss. Everybody get back to work.
How do you feel?
I'll let you know. When they come home.
The President's message said, you go forward this morning on a daring enterprise, and you carry the hopes and prayers of all Americans with you. And astronaut John Young, the commander of the mission, replied, that's a right fine speech. We sure appreciate it.
This launch of Columbia marks NASA's first manned test flight ever flown into space with people on board. Coming up on the 5-minute point, mark T-5 band counting. After Friday's failed launch attempt, it does appear that the shuttle will take off as scheduled today.
Yes. See, these are the different keys.
Sean's very easy to get along
We're gonna go see the empire.
I just want to.
Can you reach your leg there? No, I don't think so.
Imagine driving something like that.
Is it inside of the Atlantis?
We're flying in Neptune.
Yes. Come in, Capitan.
Sorry, but we have to take off.
If we take it off now, how high are we?
1, 2, 3, 1, 5, 6, 7, 8.
1 millimeter, we're that high.
Capitan, we need you here. Go.
2,000 meters up.
1,000 meters?
Come in.
Oh, you can sit
Let's
in
go
it the
this
other
way.
side.